object at rest remains at rest unless acted upon by an unbalanced force.
The ball doesn't move because no unbalanced forces are acting upon it.
If the net force acting on an object is zero, then the object will remain at constant velocity.
The ball remains at a constant velocity.
If a net force is applied to the object, then its velocity changes.
The ball that was at rest is now moving at constant velocity because Rachel pushed it. Now the ball is at rest because an unbalanced force, the wall, stopped it.
F stands for force. A force is a push or pull. M stands for the mass of the object. A stands for the acceleration of the object. Use the formula F equals m times A to find how much a 10-kilogram box accelerates with a 100 Newton force. Plug in 100 for the force, 10 for the mass, and the acceleration is unknown. When you divide 100 by 10, you find the acceleration, which is 10 meters per second squared. When the mass is constant, the acceleration is directly proportional to the net force.
The balls have the same mass, so their acceleration when they bounce off the wall is equal to the net force applied.
When the net force is constant, the acceleration is inversely proportional to the mass.
If two objects of different masses are applied the same amount of force, the lighter object will accelerate faster than the heavier object.
For every action, there is an equal and opposite reaction.
Rachel is pushing on the wall, and the wall is pushing back on Rachel with an equal force, but in the opposite direction.
The action and reaction forces act on two different objects.
When Rachel pushes on the wall, there are two forces that result from the interaction, a force on the wall and a force on Rachel.
The forces on each object are equal, but the acceleration depends on the mass of each object.
The panda and the paper have different masses, so they will drop with different accelerations, even though they were dropped at the same time.